An explosion will provide a force that pushes objects away from the point of origin. So if you say push 2 trolleys away from you, that would be considered an explosion. But if you think of an example of an explosion, you'll probably think of a bomb. This is a device that suddenly releases a large amount of energy from a chemical reaction. When the bomb explodes, the release of energy creates an outward force that pushes everything away from the point of the explosion. But what gets pushed? Well, normally in a bomb, you'll have little pieces of material called shrapnel. These particles are projected away from the bomb during the explosion. And here, when we say particle, we mean objects with mass, but where we don't consider their shape or volume. Now, what can we say about the motion of these particles? Well, the total momentum of these objects is the same as the total momentum of the system before the explosion. Remember that the momentum is the product of the mass and the velocity of an object. It's a very important quantity, as the total momentum of a system will always be conserved unless an external force acts on it. Here we can treat the bomb and the shrapnel inside as a closed system, since the only force is the explosion caused by the bomb. Now let's assume that before the explosion, the bomb was stationary. So the total momentum in the system before the explosion was 0, as nothing was moving. Then after the explosion, we can take the vector sum of all the momenta of the particles. If we do so, we'd find that their momenta adds to 0. This is because momentum acts as a vector. So if a particle has momentum in one direction, that would be cancelled out by particles with momentum in the opposite direction. So since we start with 0 momentum and end with 0 momentum, the total momentum has been conserved. This example shows us a general idea of how to work with momentum in explosions, but in your exam, you'll likely only come across one-dimensional examples with only 2 or 3 particles. Let's take a look at the most common of these. A gun will recoil when fired to balance the momentum of the fired bullet. So here we have a gun, which is initially held stationary. When the gun is fired, the bullet inside is hit by a hammer, causing the chemicals in the gunpowder to react and explode. We'll call this an explosion in the physical sense, as it creates a force that pushes objects away from a point. This explosion causes the bullet to fly out of the gun at speed. It has a large amount of momentum, which we'll call P. But remember that we initially had no momentum, so we can't now have a total momentum of P in the system. This is why the gun recoils and moves backwards, so it can have the same momentum P, but in the opposite direction. These momentum vectors are equal and opposite, so they would add to give a total of 0. Thus, the momentum of the system is conserved after the explosion.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!